All right, pH. You guys have used pH before in biology. Obviously, we touch on this again in chemistry. We've been talking about acids and bases a lot. So now we're going to talk about how to calculate pH, pOH, the hydronium ion concentration, the hydroxide ion concentration, all of that. So we're going to go through those formulas and stuff. But first, just a little definition of the pH. It is a numeric scale, 0 to 14. Or that's a general scale, is 0 to 14, where 14 is the most basic and 0 is the most acidic. And then right in the middle, we have water, which is neutral, a pH of 7. Here's some examples in this picture of things that tend to be acidic. Notice that they're actually a lot of things that we ingest. So coffee, tomatoes, lemon. We have acid in our stomach, butyric acid, battery acid. And then a lot of our bases tend to be like cleaning stuff. So baking soda, ammonia, bleach, soap, the tablets that you put in your stomach, like a Tums, when you're trying to settle it down, we have stomach acid in our stomach. So if you have like an upset tummy or what people call like acid reflux, a lot of times they'll take like a Tum or something like that, which is something that's slightly basic and can counteract that heavy acidic feeling in your stomach. pH calculations. This is sort of a chart. So the linked slides, I would definitely save this slide. You can even take a screenshot here, pause it and take a screenshot of just this little table. I think it helps you remember like what's going on. But basically we have 4 equations, and they're the ones that are here in the middle, or the ones that are on the outside, actually, however you want to do it. But the ones on the outside are sort of the rearranged versions of what's on the inside. But it's how we can, if I give you the pH, you can calculate everything else. Normally, you'll be given like the hydronium ion concentration, in which case you could calculate pH, you can calculate the OH concentration, and then finally pOH. Usually when we're reporting the like acidity or basicity of something, we're using pH. So a lot of times you're given other stuff and asked to find pH. That's typically how you're going to see questions, but you can go the other way as well. A lot of times you'll ask for the hydronium ion concentration too. Those are probably the 2 most common questions. Here's an example. You'll see more examples in the notebook, the linked examples in the notebook. But here's just one that's written out, and I'm just going to talk about it a little. So it says, given 1 gram of sodium hydroxide, what would the pH be in a 1 liter solution? So as we know, to get concentration, this up here, to get my hydrogen ion concentration is moles of the solute over liters of the solution. So I would do this all in one step. This person didn't, but you would have to take your mass of sodium hydroxide, convert it to moles, then divide that by the volume of the solution to get the concentration. And it is a base, right? So that means we're actually finding this, the green hydroxide ion there. You would need a balanced chemical equation to show that 1 sodium ion is equal to 1 hydroxide ion. It's a 1-to-1 mole ratio. So you can do the conversion from 0.025 moles per liter of sodium hydroxide and it's a 1-to-1 ratio of sodium hydroxide to hydroxide ions. Therefore, it's the same molarity for the hydroxide ion. Then we can use, again, we're finding the pH. So now that we have the OH concentration, this person who did this specifically went to the hydronium ion concentration and then to the pH. They could have gone pOH and then to pH, but they went this direction. So they used this formula here. The hydronium ion concentration equals 1 times 10 to the negative 14. That's the water constant. And then divided it by the hydroxide ion concentration. So that's what you see here. So here is the 1 times 10 to the negative 14 divided by my hydroxide ion concentration will give me the hydronium ion concentration. So that 4.0 times 10 to the negative 13 molar, that's now my hydronium ion concentration. So now I'm going this way, which means I'm going to use this equation here. This pH equals negative log of hydronium ion concentration in order to find my pH. So that's what you see here. I plugged it in, or I didn't, but this person did. Negative log of 4.0 times 10 to the negative 13 gives you 12.40. Just as a side note, the number of sig figs for pH, the two values, like the two numbers before the decimal, don't count as significant ever. So if somebody just gave me an answer that said pH equal to 12, that would have 0 sig figs. This has the 12.4 pH has 2 sig figs. I gave you 3 in the question and 1. So technically you should have given me 12.4 as an answer. If I had given you like 1.0 here instead of the 1 liter, then this would be the correct answer of 12.40. So just keeping that in mind. I wrote the question, but somebody else did the work. So actually I see it is 1.00. So with 3 sig figs here and 3 sig figs here for the mass and for the volume, we should have had 3 sig figs in our answer. So that would have been 12.400. Again, the two numbers before the decimal for pH, or one number if it was like 1 point something, any numbers before the decimal for pH don't count as significant. Only the values after count as significant. So when you're doing sig figs, keep that in mind. There will be more examples in your notebook, so please check those out.